Cool. So it's been a long break, and basically kind of almost forgot everything that I was doing. So I kind of figured out that maybe as a last video for the year, I'll kind of try to just do a cleanup. And I kind of started thinking about the fact that maybe I'm doing it wrong to just couple the whole thing to HyperNetX, and I should just use my own implementation of a node and an edge, just something very simple. Because after playing with all these, I kind of realized that the way that I'm using this is a bit simpler than just a general hypergraph, in the sense that you're not going to have, I think you're not going to have nodes belonging to more than one edge, really. And I think I can just then, work around a lot of the problems and just use the HyperNetX to draw the stuff, right? So kind of like have a print function that actually creates a HyperNetX thing and then just prints it out. But then really kind of have here, how do you do classes in Python? So Python classes. So Python 3 classes. So probably just do something like class node, right? Something like this. Def blah blah blah. Class name. Okay, and then the statements. So okay, and then you instantiate it like these. So you can have any data in there. So I can just say class node and then have sort of, I guess we need to have, like qubit, or we just need to have like qubit, which by default will be Q0 or none. And then edge. Now I'm thinking, I think I will just even force this to be just one edge. And it has a state, obviously, which is basically which is basically these, right? So is it kind of it's created so the content references, okay, and then functions. So then there's basically like a we're going to define an init. Okay, cool. So we're just going to define an initialization function that kind of is the self, and then is like the qubit, and then it's like the state, right? So just basically qubit self state equals state. That's it, really. And so yeah, why not edge? I mean, edge could just be none, right? Equals edge, because we can just, I think that's really all that we need so far. And so in terms of edges, or hyperedge, it just has an amplitude, right? And it just has, and the amplitude is also a complex number, right? So we will initialize it like I don't know. We should have a default value, and then just amplitude, right? So amplitude equals amplitude, and then I think it just has nodes, which is an empty array. I'm not going to define for now any like add node or remove node and stuff like that. We'll see what we need really. But this is just going to be, this is not going to be a bunch of nodes, but it's going to be maybe, okay, so actually I do need maybe the UID, right? And so the thing is get UID, and so this also needs a UID. I don't know if that's good practice though. And so I think I can just initialize it here, so I don't have to call it outside. Get UID node, like, is there a get UID edge? Yeah, edge. I don't remember. I really don't remember. Self UID edge, and this is self. Okay, so this kind of basically gives it the UID already. So okay, cool. And I think that's it so far. So in the UID, the qubit, the edge. So that's a string. That's a string. That's a string. So UID of the edge, and that is basically array of strings, node UIDs, right? And that is a string. Cool. So I think that's all I need, a node and a hyperedge. So now the question is, do I need all these functions? Get node labels, get edge. This is okay. From the get entanglement and get entanglement edges. Like I think I can just now basically have a class hypergraph that has got like basically nodes and edges. That's it. That's all it has. That's really all it has. And so cool. And so another question is, what do, because I think that's going to be, that's good to do this a bit of a harsh refactoring. It's going to be a good exercise to recap a bit of the stuff that I have been working on. So what next? So we have all this gate stuff, node, hyperedge, hypergraph. Where do we start? So let's just start with a single qubit gates again, right? Merge, merge, merge. So this is kind of what I was playing with here. Is okay. So I get a system by saying like from state vector, right? So I think that's the yeah, that's kind of like what I should focus on from state vector. So what it does is it creates a system, and it creates two nodes initially. So it's just like an example. So the way I would go about this is I'd say system. It's a new hypergraph, right? Or without new, just like this. It's a hypergraph. And now I say, okay, so now I gotta go to create node. So what create node is doing is it gives it the system, the initial state, and the qubit. But now I can just say basically you know, qubit 0 is equals like node, and I say, so how do I initialize a node? I can give it the qubit, the state, and the edge. Qubit state edge. So you just say Q0 state is the initial state, and that's it. And now I just say Q1. So this is qubit 1 initial state. That's all I need to do, right? So, and then of course I need to do system nodes. So this is at least, can I just like Python append list element, append extend to a list in Python. I think I've checked that probably 10 times already. Append, insert. The end at least, just append. So I'll just say append Q0, append Q1, return system. Yeah. So if I do these, and if I just basically run through these, and then here we will just comment all that stuff. So this is all commented. So all I do is I do from state vector, and then I'll just print system hypergraph object. What is this? Is hardcode institutionalized? Where is that coming from? Okay, just nodes. So it has the objects and stuff like that. Okay, so now what I should do is, actually these should have, let's do it like this. So the hypergraph should have a function that is basically called draw. And what this function does is basically it creates a nodes and edges. So hyper net x. What is the documentation? Yeah, because I think that's going to be good, because it's going to be also, it's going to allow me to, it's basically going to allow me to decouple this from that and then port it easily to some other libraries if I need to. So hypergraphs, how do I create one? So either like with the edges and the nodes, okay, or just or just add edge. Okay, so I guess Okay, we'll see. So far, no, but I would need to actually, I'd like to actually do that now. So what I would do is I would say, so I basically, so so this is just AG basically H and X hypergraph, right? Is that the right way to do that? It's just an empty one, hypergraph, and then it just like add element, right? That's the add element item. Not add node. Add nodes. Yeah. Add node to edge. Okay, it's going to be an edge. So we're going to have a dummy edge called the system edge. Yeah, okay, so we're going to have like a system, and we're going to call it like entity system, and then we're going to just have, say add edge system, right? And then we're going to just basically do right now. Okay, I'm gonna be improving these, but like for node in nodes, for if I in nodes, add node to edge, it's node n edge. So this is the node. So let's just add, so node is basically entity, and I give it the UID. Do I have to UID and then the elements and the properties? Can I just copy that from? Can I not just copy that from here? Entity. Okay, yeah. The node, the state vector, and the qubit. Yeah, exactly. Yeah. Oh, so I can just create the edge like that. Okay, so I can just do it like this. So I don't have to create the, where am I? I am here. So I don't have to create the edge. No, here hypergraph. So I don't have to create the edge system. So I do the hypergraph iterate these and then create, yeah, basically create the node like that. So this is AG, and then the UID is basically nodes UID. This is empty. The state is just, yeah, so this is just basically state, and then this is just basically qubit. So I just do this and add this like that, and then what I do at the end is a draw. Can I just do it like that? I think so. And so I'm going to call this now system draw and see what happens. But one was given. Yeah. Oh well, maybe self. Okay. That would explain self. Yeah, okay, and then self nodes I need to do. It's not, name nodes is not defined. Yeah, okay, that's all self stuff that I'm missing there. Yeah, I think that's gonna be definitely better, because I can do these so easily. So this is self nodes, and this is self nodes, and this is self nodes. until I'm gonna probably clash with something that I don't like. Listen, because integers or slices, not node. Oh, so that's already the node. Yeah, okay, because it's just a list of nodes. Oh, because actually, I should, or I think it's better if I use the IDs. So I've used a dictionary. So what I do is I say, I don't append, but I say nodes q0 UID equals q0. So if I do it like this, then it's going to be better, because I think I'll be able to just search for stuff better. What's the problem? Not strings. Well, then it's a dictionary, maybe. I should define it as a dictionary. So, as an empty dictionary. Maybe that's the reason this is being so picky. It's no attribute draw. I hope that was a good idea just to start messing with these. Hypergraph, def draw. So what one doesn't have, object has no attribute draw. What it does, right? Class hypergraph def draw. So Python 3 classes. How do I do that? Def. Do these, do that, whatever. F self. So that is the hypergraph has, it actually has these, right? It defines the draw function. So what is the problem? Okay, that seems to work now. So what I want, okay, so maybe that's the hypergraph thing. What was not? HyperNetX documentation. So hypergraph or drawing. Oh, come on. I should actually have this here. I can just drawing wrap and draw system, just like that. Okay. Okay, it's not yeah, it was not a method of the hypergraph. So it's not these, it's like these. And it's AG. So why is it not working? Nobody knows. Why is it? What is these? Why is this printing? think I should just move that to another cell. Can I just move that to another cell? Like I said, printed something, but it's like empty. Okay, so printed something empty. Why? Return the system. Hypergraph. So gets a hypergraph. HG add node to edge node to the system. Draw HG. So add node to edge. Oh, must belong to self edges. So actually these must be there. Okay, so what about that? I create something called system, which basically has a so it's just okay, cool. So now it adds the nodes and all that stuff. Okay, that's cool. System. So it prints the stuff. Can I give it all this custom stuff that I had here? So can I just copy these? Will this still work well? It should work well. Just changing these with ng. So edgy, amplitude. Yeah. The edge, the system edge should just have like. Okay, so this indeed I need to do. So amplitude, just want to be consistent. Add edge. Okay, cool. Now it's printing nothing again. Let me see. There's so much stuff. I keep getting distracted. So I get the system edge. Hypergraph. Add the system edge. Oh, Jesus. Okay. Sorry. AG. Now it's all cool. Okay, perfect. There we go. We're back at. So this is just system one. Okay, cool. Now I don't care about the system edge here. It's just representation. It just seems like I have to have one, but I really don't care if I decouple these. So I think that's gonna be a good thing to do. So but in theory, what I should do now is I should also just so that's just I'll have to modify that because these just adds them to the system edge. But it is not what you want to do. You want to actually add them to their edges, right? So if the node has edge, and so what you want to do here is, in reality, is add them to node edge, right? No, to so you want to add the node to the edge, and you want to actually first iterate over all the edges. Edges, and create the edges, which basically it's self. So this is edge, and then this is self edges UID. Then elements is empty, and then we have only a property called amplitude. And then it's self edges amplitude. That's all we would do. So we have the edge, and then we add edge, and we add the edge. Okay, cool. So you go through all the edges, you add all the edges, then you add all the nodes, and then you add the nodes to their respective edge. I think that's that's basically the only thing that we should do, really. So and maybe then we should just do this already, and just as a fallback say, well, if because this is supposed to be 1, so if edge is none. Okay, so if these is none, then basically add it to the system, else add it to the proper edge. Yeah, okay, cool. If not, we have like an empty system edge, just in case it's just a backup. I mean, that should work. Yeah, okay, that works. Awesome. Now, that is good. So this means that we have a hypergraph with a draw function, we have a hyperedge, a node, and all that stuff. Now, where was I? I was at here. So we've basically managed to do that, so we can get rid of these. Cool. So from state vector. Cool. So this is the first thing that we need to do here is from state vector. Yeah, okay, perfect. Now apply. Now we do the apply gate thing, right? So the apply gate, how do we do this? Do we need to refactor here anything concretely? Probably not. So we want to run the apply gate Q0 Hotmart. So apply gate is here, apply gate. So it's a system. It takes the nodes. There's no cleanup needed. So all that we do is actually we iterate over the nodes. We don't even need to clone anything, so system nodes. So we get the node, and then if the node qubit equals the qubit, so we get all the nodes for that qubit. Yeah, that should actually work out of the box. So let's see. Node is not defined. System. So this returns a system, and then so here I return a system. The system definitely has nodes. So which nodes are not defined? Oh. system nodes, definitely. Probably can put that into the, oh, sorry. I probably can add the whole, all these functions then can probably be just added inside the hypergraph class, but like system nodes, okay. That should do it. Yeah, okay. Okay, that's wrong. That has actually, what the heck is this happened here? What has happened here? So we take a look at the nodes. Node state, we do these, right? And return the system. We're not doing anything else. So why there is now all of a sudden, I don't get it. Oh, come on. No, 1, 2, 3, 0. What the heck is going on? Oh, maybe. Oh, I gotta. No, do I have to? Yeah, something's wrong with the. So from state vector thing. Let's calling this here. From state vector. What is this doing? From state vector. It's got a new hypergraph every time. Okay, I get it. Okay, so yeah, that's the problem, is it's creating an. It doesn't matter. No, that works. Okay, yeah, but that works. And yeah, now it's gonna. Yeah, it's something with these not being global, I guess, or being actually global and being reused. I think that's what's happening here. So I think I might as just well. Get rid of these so far and just initialize the system here, because the from state vector will just be actually a way to create the hypergraph itself here. So yeah, so if I now do these, huh? Why is it just creating the hypergraph always like from scratch? Okay, give me a second. Okay, so I paused like for 5 or 6 hours, but I'm back. So I kind of again forgot a thing where I was. I hope this is gonna. I really hope OBS is just genius if this works. So okay, anyway. I just realized that I'm making some stupid things here, and I can already just clean up as well a lot. If it just, like, it can take all the initialization, to be honest, like, you know, to be part of a basically like the init function, right? And we'll just have maybe give it the amount of qubits that it's gonna have, and then basically what it's gonna do is it's gonna go and say for I in range 0 and b qubits, basically do like nodes. Okay, now so we create nodes. So node equals. We'll just basically use the convention that we'll just append I here, and then say node UID equals node, and there we go. So this is just how we initialize the system. And so I'm basically gonna do here two. So we give it a we do like a 2-qubit system. Hypergraph takes no argument. I wonder why is this wrong? Hypergraph 2. It does take, right? I've just oh no, in itself and b qubits. Yeah, it does actually. Oh, there you go. That is the problem. Casting. Seriously. Concatenate strings, not ints to strings. I think I can just. Can I just do it like this? I think so. NB qubits from state vector. Wait a second, but I'm not. Okay. Oh, I was creating 2 hypergraphs. Maybe that's why the system was. Okay, no, whatever. So there you go. Perfect. Okay, cool. And apply gate can also just be like, come on, that just like, it can be part of the class, right? So it just can be part of the class, and it does not need to return any system because this is basically self, and then the only thing that it does is self nodes. So if the so basically if the qubit is the one that we're applying these to, then we apply the gate. Exactly, and so now apply gate is just basically a function of the system. That actually looks nice. Oh, it doesn't need system anymore because it's self. There you go. Okay, perfect. Something's wrong though. How am I initializing the qubits? Initial state. What is initial state? I have the impression that it's What happened? What happened? What? Oh, it seems, what? So, so, what is apply-gate doing for uh, self and qubit and gate and so for n in self nodes? If self nodes and qubit equals qubit, we apply gate self node and state equals np dot gate node state, not node state, but this. Why? What's wrong? Okay, that's correct. Apply the second. What is wrong with the second? Q1. Oh, come on. What the heck is going on with the system here? Like, so I'm just gonna make insert cell both, and I'm just gonna do this here. Why is this all happening? Tell me. Why is this just piling up new things instead of hypergraph? So I'm creating an empty hypergraph. What is apply-gate doing? It's just updating the state. It's not touching anything else. Oh, oh, this is really wrong. Okay. Yeah, that's a mess. Because system is a self. That's the main. I think that's the problem. Okay, there you go. Yeah, there you go. No. Oh, jeez, come on. Like, are you kidding me? Do I have to every time I initialize these? So where's the word system used? Like, only in here, right? I'm creating the hypergraph. It has empty nodes. It's got empty nodes, and it's got add node to edge, add node to edge. Okay, so it's this is also a new hypergraph I'm creating every time to print stuff. System. Like, why? Why is these? I don't understand that. Okay, maybe what I should do is I should initialize always. Yeah, maybe I should just initialize always these. I'm not so sure if this is the issue, but it's I haven't played with object orientation for a while, and actually in Python at all. Okay, so that seems to do it. Okay, so now I can do these. Yeah, okay, cool. I like that. Now, what about the multi-qubit one? That's gonna be the nice one. So I mean, what do I have, right? So what do I have? I have applied 2-qubit gate system. Okay, so these are the nodes of the qubit 0. Okay, so it looks like I should probably just, I think, take that over and implement a so I know this had a lot of open to-dos, right? But like, yeah, I think I'm gonna get rid of these stuff in here. Get qubit edges, get qubit nodes. I think that's useless as well. Get untitled edges, that's useless as well. That's useless as well. This is important for get UID, create node is also useless, create qubit edge is also useless. Now that I have these functions in here, so okay, but let's apply gate now. We want to apply a 2-qubit gate. So what do? The first thing we do is, well, this is self, and this is going to be basically, you know, the qubit 0 and the qubit 1. Maybe I should just call it qubit A and qubit B, or just A and B. Okay, and then the gate. Now I need to basically, what I need to do is I need to get the nodes, so I'll just do like self get qubit nodes, and I'll give it qubit 0. So, and I have to actually code this now, but that should be an easy one. Get okay A, so that's the way it should be. B nodes B. Okay. So now, how do I do this actually? Def get qubit nodes, and then qubit. So actually, what this is just a iteration, right? And so what we're gonna do is we're gonna get a really just a list. Okay, sorry. So result or just nodes. It's an empty list, and then for n itself nodes. If self nodes n dot qubit equals qubit, then append self nodes n, exactly. And so return nodes. So that's what it does, nodes. No, actually it should node, it should return UIDs. Let's do it like that. So what it should do is it should append the UID. It returns the UIDs. node IDs, qubit node IDs. Because I can then quickly reference to these things internally without having copies of the qubit and stuff like that, making sure that I'm always getting the right state. Cool. So I have node IDs, I have node IDs, perfect. And so now what I do is, so for AI ID in AI nodes IDs, for BID in B node IDs. So what I do is okay, so I have to get the local 2-qubit state vector. So what I do is self nodes, and now I do AID and state. That's cool. That's neat actually. So I get these, and then I multiply by the gate. So and now I have to do hard-coded. Okay, so now I have to do kind of like a hard-coded, so that's like the range, yeah? Okay, so that's the session touch probability, blah, blah, blah. Okay, so now we're creating the edges. Now, this is where I have to change things here. Okay, cool. So what I have to do is I have to create these edges, which are basically these hyper edges here. Hyper edge just needs an amplitude, right? So what I do now is I do edge I is basically hyper edge. Is it just like these? Hyper edge. Do we just give it the amplitude? Yeah, just give it the amplitude, hyper edge. And that's the amplitude. So everything else goes away. So now I have the edge. Now what I do is I do self, or I just like self edges, right? EUID, so I'm gonna call this just E equals E. So I'm adding this to the edges, and now I actually create the nodes. Okay, cool. So it should say excited state. So what I should do is I should do basically, is it just node? Did I just call it node? Yeah, node. And what do I give to the node? The qubit and the state. And the edge, qubit, state, and edge. So I say node is the qubit 0, so basically A qubit, state, and edge. The state is these. And then the edge is the EUID. Exactly. And this is basically the same. No, this is so this is node B and EUID. Exactly. So cool. So I now don't need to do all these add to edge stuff. So that's much simpler. and I need to print all this stuff. Okay, cool. Yeah, so that's all it does, right? So it doesn't really do the merging here. It just, what it does is it just creates all the branches based on these. Okay, that's not complicated. Apply to qubit gate, apply gate, apply to qubit gate. So qubits are not entangled. We operate at the hyperedge level. True. If they're entangled, I need to apply these. Yeah, but isn't that already working like that here? So for every So if I have like two hyper edges and I have two nodes for A, two nodes for B, so what we want is that this happens only for those nodes that share the edge. Is that correct? If the qubit is different and they share the edge. Yeah. So what I should do is I should say basically if so self nodes qubit is different than this qubit. But at the same time, edge, is it? I called it edge. It's edge ID, right? It should just be. I think that's easier. Edge ID. Edge ID. Self edge ID. Okay. So edge UID equals edge UID. So if they are in the same edge, right, and they so if they are from the same edge, so different qubit and same edge, right? Well, yeah, they're obviously different qubit, right? But I'll just in case, that is obviously, we assume different qubits. Okay, so let's put it this way. We assume A is different than B, so we don't have to control for this, and so we just say the edge must be the same. Okay, interesting. So now let's try to do the following. Actually, where should I put these? Should I just? I think I just should clean this up. So this is now just the actual classes and the gates. So I just should put this probably here at the top. As helper functions because they just bother me there. And then, to be honest, I think I can just take all these, edit, delete cells, and I can just insert cell above. Cool. So far so good. No, it's not good. Edge ID. Oh, hyper edge. Self UID. Blah 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 blah. Node H UID. Okay, so far so good. Now, if we say apply to a Qt gate, right? And itself, and it's like A, B, and gate. So it's going to be Q0, and then the gate is going to be a CX gate. So CX 0, 1. What's going to happen first without these? So we've got this node, and now if we do this, it's going to break to a given get given node like this. So obviously self is missing. What else we have? Nodes is not defined. Nodes is not defined here. It's UIDs, obviously. Get some extra light in here. What else? Reference before assignment. Node edge. So for our self edges, what? Add edge. It's not node. We're adding the edge. That doesn't need to exist. Okay, so it's adding the edge. Cool. Okay, perfect. So now it's got okay, so wait a second. I think I'm missing something here. So, first of all, I'm creating the nodes, but I'm not adding them, right? So that's wrong. So I should say self nodes p uid equals p. That is the first thing. It's self nodes p uid or q uid equals q. That is essential. Why has these added the edges in the wrong place? UID. So what does node do? Gets the UID, the qubit, the state, and the edge UID. And then I need to add it to nodes, obviously. What about the edge? Have I added the edge? Have I added any edge? Hyper edge, self edges, UID. So what if I print len of self edges and print len of self nodes. Doesn't help me much. Why is it? Okay, 2 and 6, yeah. Do I just 6 nodes? What if I bring P and Q? Oh, okay, node object, whatever. Um, okay, so the node states seem to be the correct ones. 0, 1, right? Now, so that's correct. I think it might just be off with the draw function. So what is it doing? So it well, and I need to clean up. What I need to do is I need to clean up the A node IDs and B node IDs, right? So Python remove dictionary elements by key. Pop. Pop key to be deleted. Okay. So Python pop list. Pop. Pop position. Python pop dictionary. And what is it doing? So it's adding a system edge, right? And then it's basically iterating over the edges. It's adding the edges. So it's correct. Add edge. Oh, okay. So add a node to so edge. It's called edge UID now. Maybe that's why it's not working. Yeah, awesome. So these two stay here, right? So yeah, I gotta deal how to. I gotta figure out how to get rid of these stuff, but yeah, of the system node. So 1 1, so 0 0 1 1. That's awesome. That makes total sense. That actually works. How do I pop stuff? Key name. Okay, so I think I can just pop the element. So I think I can just pop the element as I iterate over them, right? So because I really don't need that stuff anymore. So here, after these, I just like pop nodes. So I just say self nodes. I'm assuming nodes only belong to one element. So what I will do is I'll just actually put that in a function. So I'll just say self delete node, and then I'll just give it the AID self delete node. And so, you know, if I need to make it more complicated, I'll make it more complicated later. Delete node. So what this should do is basically delete node UID. So what it should do is we're assuming one element, assuming node exists, self nodes pop node UID. Awesome. Right. That's that easy. Delete node self. There you go. There you go. There you go. Can I check? Could I just? Yeah, maybe I can't. Like, if the edge system. Yeah, I could check if system is empty. Or I'll just do it quick. It's just really dirty. Empty system is false. And so as soon as like I add something, then I'll just set it to true. And then I say if empty system, empty system is true. And so if empty system is and then it's false, and so if empty system, then delete edge. System. Can I do it like that? I think I can do it like that. Delete edge, remove edge. Yeah, perfect. Okay, so now it's a bit cleaner. So, and basically system will just, yeah, those are not entangled qubits, I guess. Okay, but now that makes sense. Cool. So now what happens if I make another control X gate? Is this going to work? I don't know, but it's much cleaner. So I think I'm actually done with the refactoring. So I'll just commit that now. So I have these. I have the gates. This is not used. Is this used? Node NB. It's used by. Oh yeah, it's used by these. Okay, but by get UID. This is get node labels. Okay, so actually it's pretty clean now. I have all this stuff here. I have a node hyperedge, I have a hypergraph. It's not really a hypergraph, really. This is actually, it's actually my system, right? So I should rename that. and I should just call that hyper edge, also give it another name, but whatever. So I have given node IDs, delete node, apply gate, apply to cubic gate. So that applies to cubic gate, but doesn't do the merging. So that will be the next. The next step would be to go and take the merge edges thing, which was, and because that's what I was testing here, is what happens with the second CX gate, right? Because what I was trying to do here is I was trying to basically apply that to each entanglement edge, and I think that was just too complicated. Now that made it easier. Because all I need to do is, I think I'll be able to just delete that, to be honest. Second CX gate. Yeah, I think I'm just gonna get rid of these. Edit, delete cell. So this is the stuff that's still to be ported. Inside a class, because now basically what I can do, I mean, let's see what happens. Okay, so in theory, what this should do is it should take all the nodes from qubit 0, all the nodes from qubit 1, but only apply the operation for those that share an edge, right? Now, what's going to happen here is I don't know what's going to happen with the edge. So I'm gonna be creating new edges, and I need to clean the edges here as well. So actually, I'll probably do clean edge, right? Because now basically what's going to happen is, boom. What? Kiara, node 3. Okay. Why? It's just because I have cleaned it up already. As I... Oh yeah, of course. Yeah, but it's fine, isn't it? Yeah, okay, I know. It's just conflicting with the IDs because I'm deleting them, so it's not... Well, then I can just say, first of all, you know, they might not exist. So if they don't exist, it means I've processed them, so I just can skip them. So if Python check key exists, if key in dict keys, okay. So if ARD in self nodes and Yeti in self nodes, right? So that's the first thing that we check. Yeah, if not, we just then, you know, both must be there. What is it wrong here? This is just one end. Really? Okay, so what has happened now I think there's something wrong. no, there's nothing wrong. That actually worked. So yeah, so it did nothing here, and it actually flipped. No, the other way. It did nothing here because it was 0, 0, and here it was 1, 1, so it flipped this one. So it's actually worked, but it needed to clean the edges. So how do I delete an edge? Right. That's the maybe it should just happen automatically when the nodes are deleted. If an edge ends up empty, you know what I mean? If I delete a node, pop. So if there's if there's no other node that references that edge, because what does the edge have? Well, the hyper edge actually should have these. Oh, actually should have the nodes as well. I think. Node UID, delete node. So I should define a delete edge as well. Delete edge. Then what it does is so edge UID, and it says basically if length of self edges edge UID is 0, then basically self edges pop edge UID. So that's what it does. And so what it, by the way, what the if I'm adding a node to the edge, I should really, damn it, I should actually not do it like this here. Yeah, I should really do it like, probably replicating a lot of the functionality, but like, edge UID. So what I should actually have is here a def add node to edge, and then I have a self, a node UID, and an edge UID. And so what it should do is, so we assume, okay, so we don't assume, but we say if self nodes node UID edge UID equals none, right? So only, and if self, well, we assume the edge to exist and node exist. So then what we do is we had to basically, so we just connect them. So edge UID, and then self edges edge UID. Nodes. Should I add a copy of the node or just append? Append node UID. I think I should just do it like these. So okay, so what it does is node. So the node has the edge UID, but the hyperedge has the node UIDs, which is an array. So what this does is if the edge, so if the node does not belong, or it's fine. No, it just actually that's not needed. It's just changing. Yeah, but then I would have to double check for that. Okay, so if the UID of the edge, if the UID, so assuming you don't have to change membership, right? So if the UID, that's really hacky, but it should work for the purpose of these. So if the edge ID is none, then we add the edge UID, and then we actually add the node UID to the edge ID exactly. So I need to add node to edge. So actually, when I apply the toolkeeper gate, and I don't do it like this. I actually need to do self add node to edge. UID exactly. So so I'm adding these nodes to the edge. So first of all, I'm adding the nodes. So I'm adding the nodes and I'm adding them to the edge. Exactly. Create nodes. Add nodes to graph. Add nodes to edge. So create the hyperedge, create the nodes, add nodes to the graph. That should be, and then yeah. So delete node, what it does is just deletes the node from the system. Okay, so it should also delete it from the edge it belonged, right? So now it needs to, yeah. So UID equals self nodes node UID edge UID, and now what we need to do is basically self edges UID node IDs, node UIDs. Is it node UIDs finally, or node ID? Node UIDs. Pop. Node UID. So I remove from the edge. So we remove from nodes. and remove from the edge. And when I delete the edges, if it's empty, then it pops it up, and I assume that it's done everything correctly. Okay, so what this needs to do now is it needs to delete the nodes on the go and get the edges they belong to, then try to delete the edges as well if needed. Or I can say when I delete a node, I can try to delete the edge that it belonged to. Yeah, maybe I'll just do it explicitly here. So I'll just say um, and I'll just say the edge, so the edge UID from A equals edge UID, and then the edge UID of B equals these. And so what we also need to do is, after deleting the nodes, delete the edge of these. Yeah, exactly. So boom, key error none. Okay, so in delete node, EUID. Oh, none, because because it's deleting the ones from the system. So yeah, so if so I pop the node, and then obviously if itself edges, then we also delete it. Delete node, delete edge. Yeah. Okay, what's going on now? Delete edge. Oh yeah, okay. Same here. Delete edge. Yeah, I can give it an actual none. So if edge is in self edges, and then this happens, then pop it up. Oh, come on. Huh? If edge UID. Okay. Oh. Keys, and actually should the same here. Keys, right? What else do I use? What else do I use in keys. Nodes, keys, self nodes, keys. Okay, cool. What else now? Oh, Jesus. Edges. Keys none. So if edge UID in keys. Should I just use like and then here as well, and okay, cool. Now it's good. Now it's good. As an integer, a string object can be interpreted as an integer. Ooh. Okay. So Python pop string from list. I pop a string from a list. So node UIDs. What is the problem? By index. Okay. Okay, so I should actually think it's easier. It's easier. Index off. Okay, yeah. So I should just pop the Python index off. So what I should use is so in the delete node UID. So I want to remove the self so I want to get the index. The index of node UID. So index off. I think index off works, but I'm not so sure. List index method. Index. So what does it give? Vowels index E. Okay, just like that. Vowels index E. So if I say just index, so I want the index of the node, and then I just pop the index. Correct? Okay, cool. Yeah, I think it worked at least. And then this length is somewhere hyper edge. Yeah, because it's the edges and then node UIDs. Exactly. So many mistakes. Okay, there you go. But it didn't delete the edges. It didn't delete the edges. It didn't delete the edges. Why? Delete edge. Edge. UID. Delete the elements. But it didn't delete the edges. So let me print self edges pop. Print these. Two 5 5. So it should actually delete them at least the second time. So delete edge. Is the edge still there? And then is the length. Or basically print these. So assuming this is in there, please print that stuff. I think I'm just not removing them correctly, maybe. Yeah, I'm not popping these things out. Okay. 6, 7, 9, 10, 6, 7, 10, 9, 10, 12, 13, 9, 10, 12, 13. So delete node. So it looks like the delete node is not popping up. If pop the node, if HUID in the keys, then get the index of this node. Print index, print I. Zero, zero, zero. Okay, and so what are we searching for? So it seems like that's the node you index off, and then we print this. Node 7, 0. Am I checking the right thing? I'm checking in the edge the node UIDs of the edge. The node UIDs of the edge. So the edge, we know it exists. Then we get the node UIDs of this edge. Index of, okay. It says index of, and then node 4, node 6, 7, 9, 10, node 4 is index 0. Index of, yeah, it's index 0 is what we're popping. So it is indeed the index 0. So after I pop it, popped. So yeah, actually it worked. It's now popped, but it has nodes 6, 7, 9, and 10. Why? Why it's got so many nodes? Why it's got so many nodes? That's okay. So the deletion is okay. It just for some reason it's got for some reason it's got too many nodes. Add node to edge. So if the node is append node UID, so if the so what about me printing here? Print edge UID, node UID, edge UID, print this stuff. Three to H2, 4 to H2. Three, 4, 6, 7, 9, 3, 4, 6, 7, 9 to H8. Node 9 to H8. Why H8 has got so many already? Why has H8 got so many? I have no idea. That's so confusing. Maybe because I'm doing these. Maybe because I'm doing these, yeah, for all possible combinations. But as I said, like, if the edge ID are the same, oh, okay, and I haven't done that before. That's probably the problem. Yeah, but if I remove the nodes, kind of it means I've used them already, right? Because if I delete the node, AID and BID, come on. How many times is this done? Let's just print AID. BID. BID. 0, 1, 3, 4. Where do I have prints? I don't want to print this. I don't want to print this. That's all. That's all good. No 0, 1. 3, 4, 6, and 7. It's correct. That kind of, for some reason, the let's try one thing. Let's. I think the problem is for some reason this part here, which I'm currently not using, so I'm gonna just not add it there. It's buggy. I'll probably just leave it here. Node 3 is not in the list. Delete node. Oh, sorry. So now I also gotta delete node. So I'm also gonna just comment these because I think it's buggy. Yeah, okay, that works. So it's just then buggy. Perfect. Yeah. Okay, I'm gonna leave it here. I think I've almost got it refactored. So it's a bit of a long video, but it's it had to be done. It had to be done. I think so. It's buggy is these part here. So why am I adding HUID? Why am I adding add node to edge? Oh. It's the EUI is the edge. It's not these. No, it is these. I'm adding it to the new edge that I'm creating here, right? So I'm adding it to PQ, so I'm adding P and Q. For some reason this runs too often. That's the edge that I'm creating, so I'm creating a new hyper edge. I think maybe the problem is here in the hyper edge class, and it's oh yeah, it's probably this is the problem. I'm not initializing these. That is the problem. Could it be? I don't really get it. why is this problematic? Why the default value doesn't work? Maybe that's the reason. It was for some reason just every time creating the an add node to edge. It was just creating, because I'm creating the no, I'm in the hyper edge creation, and so it kind of piled up the nodes for some reason. Ah, crap! No, it's still not working. Okay, but it's got to be somewhere. It's got to be somewhere there. So what about these? Every time I create a hypergraph, a hyper edge, I get a UID. Oh, there you go. Yes, that is the problem. Okay, perfect. That's cool. So don't print that anymore. Then we got something that works. Now next step will be the merging, and but it seems to work now per branch, and so I can just yeah, like what if I now do these? Is it going to be consistent if I do that? Yeah, so it's hard to mark this whole thing here. That's awesome. It just renders this in a weird way, but that's awesome. And the amplitude is a bit off, isn't it? Because the amplitudes here should be I think there's a bug with the amplitudes. Those are correct. Okay, yeah, those are correct, but then oh yeah, there's a bug with the amplitudes somewhere here. That I think overrides. Back. The amplitude is wrong. Even edge exists. Yeah, so that's the problem. That's a problem. But okay, but I got it to almost work, and then the merging, and then I just need to do the merging. Now that feels much better because I don't depend on HyperNetX anymore, as I just have a lot of assumptions that I can make about these nodes and whatnot, so I can kind of have a simpler system, a simpler implementation, and yeah. So then the merging is going to be like, yeah, so mergeable. Get the mergeable edges, and then merge, and then this kind of stuff. Cool, I'm going to commit that now, but stop the video. Goodbye, and see you next year.